So thanks for coming, everybody. My name is Zack Gramana. I am the senior software engineer on the Couchbase mobile team, working on the .NET version of Couchbase Lite. So before we get started today, I wanted to take a few minutes to introduce Kyoichi Kitsugi-san, who is the winner of our Tokyo Couchbase, joint Couchbase NTT Docomo hackathon, which we recently held. The teams had, yay! The teams had a few hour session kicking off the hackathon where everybody had a chance to discuss ideas for apps. And then the team reconvened several days later for a full-day event where they actually then constructed and built the applications. It was a fantastic event. A lot of fantastic apps were built, and being one of the judges on the judging panel, it was a very difficult process to select a winner. However, Kitsugi-san's team put together a fantastic app. He's flown all the way from Japan to be able to demo this for you all and to talk a little bit about what they did and how they used Couchbase Mobile to build it. Without further ado, I'm going to turn it on over to Kitsugi-san so he can demo for you.
Okay, so I'm going to be translator for him for the session because he's also Japanese. So, okay. So the application name is Memory Node. It's kind of like some guest book application. So when customer stays the hotel, there's a guest book. So the application emulates the guest book functionality. So the user can scan the QR code to get the guest book synchronized on your local database on the mobile device. And the customer can bring it home, bring the memory to your private place, and after that, they can look at the memory. So the application is kind of like that. Okay.
Okay.
So this is the winning prize, the first prize.
And maybe you could talk a little bit about the process the team went through coming up with the idea while we're waiting on the iPhone to get checked out here.
Yeah, so the concept is using Couchbase mobile solution, we can create synchronization capability very easily. And Sync Gateway also support channel mechanism so that divide the data set into small portions. With this application, the channel is a place, like the hotel or the place. So only people who actually get there can get the information stored on the local database. That is the concept of this application. Is it ready?
Oh, okay.
Okay, so demo.
映ってんですか？
いいっすよ。
では始めます。
So he's going to start demo.
これは私の iPhone です。
So this is his iPhone.
X コードで開発しております。
He's developing this application with Xcode.
スタートします。
Stage right demo.
Yes.
There we go.
Okay.
You have iPhone, take the screen.
Great.
And I'll just come switch this back when you're out.
まずユーザーの設定をします。
First of all, we need to register the user information, username and password.
これで今、シンクゲートウェイと同居しています。
Now the user can log into the sync gateway.
今、一つ、ウェスティンサンフランシスコが表示されています。
Now we have a place that rests in San Francisco,
じゃあ、場所を一つ追加します。
and he is going to add new place
スキャンコー
by scanning code
ド、Take Photo。
with taking photo.
場所は、
So the place is at the top of how do I say?
小さい。小さい。
kind of too small to take.
Maybe zoom
う
in.
ん OK 他の画像があります。
The demos.
OK 行きました。はい、今、場所が一つ追加されました。
Now the new place is added.
じゃあ、これで選択をしますと、
And by selecting the place,
コメントを追加することができます。
the user can put comment on that.
写真を追加します。
And the user can also update photo.
私とザックです。
Kyoichi-san and Zack.
ダウン。
はい。
今追加しました。
Now the comment is added.
次に、別のユーザーで入ります。
Then he's going to log in with different user.
トム&ジェリー。ジェリーの場合、この8項のとこがあります。
So now the different user, Jerry, can see the different places, including Hachiko, Chuken Hachiko in the middle.
先ほどトムで追加したデータが、ジェリーの方で反映されています。
Now Jerry can see the data which is posted by Tom.
1日しかなかったので、これしかできませんでした。
So we only had one day, actually 6 hours to develop this application.
少し、資料で説明します。
So I'm going to describe what we have done using the slide. So
They can see.
yeah,
OK
もう見えてるみたい。
見えてますね。まず最初に、シンクゲートを起動する前に、バケットを作成する必要があります。
So before starting Sync Gateway, we need to create a bucket on the Couchbase server.
次にシンクゲートウェイを起動します。
Then start Sync Gateway.
次に、ベースデータを作成します。
And we will need to put some base data.
ベースデータは少し、場所です。
Base data means places like this.
カールコマンドで、送信します。
Using call command to upload the JSON document.
それからプロフィール、
Now the user profile
それからユーザーデータです。
and user authentication data,
これはシンクゲートへの、認証で使えます。
which is used by Sync Gateway authorization.
これがコメントの、JSON です。
This is the comment JSON document.
そしてシンクファンクション、
This is the sync function.
タイプによって、アクセス制限をかけています。
So now you can see the function is checking the document type.
以上です。
That's all for the presentation. Thank you.
Well, thanks a lot.
Thanks a lot.
It's impressive that they were Katsugi-san's team was able to put that together as polished as it looks in just 6 hours. My mind is still blown by that. A lot of impressive engineering talent. and design talent. That very few developers are able to come out with something looking so solid in such a short amount of time. Yeah, that'd be fine. Thanks again, and I was remiss earlier. Thank you, Kawamura-san, for translating. Kawamura-san's one of our Tokyo-based employees. We're glad that he was able to help us out today. So, thanks.
Thank you.
All right, great. Well, once again, thanks everybody for attending today. So let's talk some .NET real quick here. For those of you who may not already be familiar with Couchbase Lite and what it is and how it works, we're gonna quickly cover the high level stuff to give you a sense of what it is and what its capabilities are. So in short, it is a document database with MapReduce based queries and indexes, and provides master-master replication, or as most people prefer to call it, sync. And Couchbase Lite for .NET is a very small assembly. It's less than 500 kilobytes, even with the dependencies. So very little overhead to add to your application. So what is a document-oriented database? So it's semi-structured data made up of key-value pairs. It's schemaless. And ultimately, it ends up as JSON, both over the wire and in the storage engine. But bottom line is it's a low-friction way to store and retrieve data in your applications. So a lot of .NET users are not familiar with MapReduce. They spent many years being told that it was evil. The interesting thing is that you are probably already using it, you just don't even realize because it's going by different names. But in short, the key differences between MapReduce queries and using SQL queries are MapReduce queries are functional as opposed to a separate set theoretic language like SQL. It's much more natural for developers because we're just writing C# functions, and we know how to do that all day long. The queries in Couchbase Lite can be done as a one-off query or as auto-updating, which you can sort of think of as a SQL query that continues to iterate, and once you get through the list of records that are already in there, there's just a really long wait before your for each loop hits the next record. And as soon as a record is saved, it would sort of iterate through. That's kind of the idea behind it. But as we'll see in a little bit, we have a very .NET-centric approach. So we do that kind of stuff via events instead. In short, the easiest way to think about doing map and reduce is like map is LINQ's select statement. It's a way to do projections or to take an incoming dictionary of properties and then convert it to whatever format you want to be able to either end up in the index and also in the result set or have it output the results that would feed into an optional reduce function. And reduce is like the aggregate method. So if you do select and then aggregate, you have a pretty good idea of what's going on with MapReduce. And then finally, sync is master-master replication. It's based on REST and HTTP, obviously. The bottom line is you get offline mode for free, which is fantastic. And it can either be done as a one-off sync that you control and manually kick off, or it can just be set and forget, where you start it and it runs in the background, and anytime a change is made locally, it gets pushed to a remote server, or anytime a remote change is made, it's pulled down and immediately available in your application. And it has lots of other networking code in there that you just don't have to worry about, including responding to network change events. So when the network comes offline, we use .NET's reachability manager classes to be able to take our replication offline, so we're not waiting for a call that never comes. Or we can take it back online and catch up with whatever changes were made during the network outage. So in short, the programming model is very straightforward. All you have to focus on is just making your changes to your documents. The queries will reflect those changes, and the replicators will sync those changes. But for you, once you've just initialized your application, all you have to worry about is just the data, which is great. Yeah. So the first place we begin with Couchbase Lite is with documents and our concept of documents. So to get documents, first off, we need a database. So we have this manager class with a singleton instance provided as a convenience. And you just simply call get database. Now there's two patterns for this. You'll notice the first one, get database, you can assert that it will never be null because it follows the get or create semantic. So if foo doesn't already exist, it will create it for us. So one way or another, we're getting a foo database out of this thing. But there are times where we want to have a strict get or null kind of semantic. So we have the get existing database, and we're going to see this pattern show up with other classes as well. But in these cases, if foo doesn't already exist, we'll get null. And that lets us do some interesting things. So like, for instance, in .NET, you can actually ship a preceded Couchbase Lite database as an assembly resource that's embedded in the assembly. So if the database does not already exist, you can unload one from the assembly and already have a preceded, ready-to-go data set. So you don't even need to hit the network to get people off and running. I kind of refer to this as priming the pump. So that way your user is able to get a usable application faster. So now that we've got a database handle here, then we just call get document. As you can see with document, we follow that similar semantic. So if we call get document, we'll get a document no matter what. If it doesn't already exist with that ID, then a new one will be created and returned to us. If we want to be able to have a more specific check, then we can use the get existing document. Creating a document couldn't be easier. Same with deleting a document. Now you'll notice real quick on deleted, the way we find out if the document has been deleted is to check the deleted property. And that's important because when you're dealing with sync, you don't want to actually delete the records because what will end up happening is the next time you sync, that deleted record is going to come right back again. So what we want to do is use a technique called tombstoning, where the object itself is there, but it's flagged as having been logically deleted. Now, from a database standpoint, we can minimize the amount of storage overhead, and eventually things can get compacted and permanently removed. But by and large, we try not to do that because we want to make sure that we won't ever get that resynced back again. So when we're done, to get started, we need to deal with a revision because conceptually, a document is actually a collection of revisions, and it's the revisions that hold the data we want. The way we handle versioning over time to enable sync is by implementing something called the MVCC algorithm. It's the same algorithm used in Git and Mercurial and a lot of other version control systems. And you can sort of think of Couchbase Lite revision as being like a commit or a change set in Git. And you can think of a document as like a branch, which is a series of commits over time. And so whenever we want to make changes to a document, it's not really the document per se that we're changing, but we're either adding revisions or marking them as deleted, things like that. So in this case, we want to create a new revision for the very first time on a brand new spanking document. And so we call set user properties with our dictionary of data that we want to store. And then we hit save and we're done. Now, if we have an existing document, it's even faster. All we need to do is create our properties and then call put properties, and we're done. Now, put properties will actually return back a saved revision object, so we can do any other additional processing or introspection that we want to do off that afterwards. By and large, we tend to just ignore it. Now, one of the great things about Couchbase Lite is that we get a lot of information about changes. And we all deal with dynamic data in our applications. CouchbaseLite.net is designed to explicitly to give you tools to manage that change effectively in your application. So things like a document here have a change event, and if a remote revision comes in from maybe a coworker changed a customer record while you were away or what have you, then that incoming change comes in via replication, and you can be notified even down to a per document basis just by providing an event handler here. So you'll notice that on the event args that we're getting passed in, we've got this change property which has some interesting things, and we've started to get a hint of how we deal with conflicts and conflict resolution. And we see that we can find out if this change is resulting in a conflicted state, so we can resolve it. We'll talk a little bit more about how we resolve conflicts in just a second, but it's worth noting we get a lot of other additional information in this document change event here. We not only get the doc ID and whether or not it's conflicted or it's the current revision, but we can also find out which server we were replicating with when this change came in, because we may not always be replicating with one and only one server, and that will certainly be true in peer-to-peer applications. So this gives us a chance to see where it came from. So handling conflicts. One of the most powerful things about the MVCC algorithm is its ability to let you manage when two people have made changes to the same record. And that's an issue that's notoriously difficult with sync. And if you've spent any time rolling your own sync solutions, you know exactly the pain that's involved with this. So just resolving conflicts in Couchbase Lite is just like resolving conflicts in Git or Mercurial. Ultimately, what we need to do is have a merge commit, if you will, where we create a new revision that has the merged properties that we want to be the resolved state. And then we create that new revision, and we mark the conflicting ones as deleted. So that way we have a final sort of merge commit like semantic. So this is just a nice copy-pastable bit of code that you can look at and use to assist you with resolving conflicts. But the long and the short of it is we're just going to create a new revision. I'm going to kind of hand wave over how we get the merge properties dictionary, and we'll look at that in the next slide. That's obviously where the hard work is done. But anything that isn't the final current revision, then we're going to go ahead and mark as deleted, and then save that new merge commit, so to speak, by calling save. So here's a little bit of code right here that you can use to have an auto merge style block of code. You know, as we know from things like Git and Mercurial and other distributed version control systems, they'll do their best effort to try to auto merge conflicts for us. But there are times when they can't. But most of the time they are auto mergeable, which is great. And so we want to just have that go away. So this is some bit of code right here using LINQ that will show you how to do an auto merge. If it can't be merged, then it's going to throw an argument exception, and then we can insert our manual merge resolution logic there, and that's going to always be dependent on your specific app. Okay, so we've got documents. Now we need to figure out how to get views and queries. We've got data in, let's get data out. So we have a concept of a view. A view is essentially an index. And these are created based on MapReduce queries. So as you can see, we can get our foo view, or our foo index, if you will. And the nice thing is we can have multiple indexes of the same data set, which gives us different views over the same data. And that's a very powerful programming paradigm. So here's a simple, trivial example of a mapper function. And in this case, all I'm doing is looking at the incoming dictionary. I'm looking to make sure that there's a foo key in there, and that the value for foo is bar. And I'm only going to index the bars in this application. And I'm going to index it primarily based on the text field, or the particular text here. In this case, this obviously isn't very useful because everything's going to end up with text as the index entry. But you can certainly do whatever you like. Or rather, I'm sorry. There's the assumption that that there's some kind of interesting things here in the text key. But these will all get sorted based on their just normal alphabetical order there. And then finally, we have reducers. And so this is an example here, which does the kind of canonical word count implementation that is sort of the standard hello world for MapReduce. And it's just a very simple, naive word count that splits up the spaces and returns back the count of words that we found here. And so we provide these to our view, and at that point, we've got our index built of word counts. And then we can create a query around that. So we just call the create query method on the view. And now we've got something that will run, and it'll iterate, and we can get the result sets back here. We can add in some other options, like whether we want to sort ascending, descending. We can either use the async and await keyword here if we want to run async, or we can also wait for a completed change handler. Now, I mentioned earlier about getting live results back. Here we can call the query we just created, this toLive query method, and now we've got this added changed event to the query. So once that completed event fires and we've iterated through the results that we currently know about, anytime new results come in, this changed event will fire with the results of whatever new records there are. So this is a very powerful way to provide sort of auto-updating user interfaces, where all you need to do is connect them up, and then at that point, you just forget about it. And as data comes in, it just magically appears in your app, which is very, very powerful. Then finally, we've got replication. And as you can see, it's very straightforward and simple to implement. So all we need is the URL to our sync gateway. We then call either create pull replication, which is a replication that brings down remote changes. And again, we've got a changed handler here, so we can see whenever things have changed in that replication. It gives us some progress indicators, things like that, record counts of what's changed. And then we've also got push replications, which take our local changes that we've been making and push them up to a remote server elsewhere. So we have push and we have pull down. I'm sorry, and the puller brings down from the remote changes. So we have push, we have pull, and you can configure these based on your application needs. If you're doing logging, then all you need to do is push. And you don't need to make it continuous in most cases. You know, you can just push when it's appropriate, maybe when your app is launching or when it's exiting. And same goes for pulling. So next steps, you can find us at the portal. You can grab the bits either through the Xamarin Component Store or via NuGet. And with that, are there any questions? Great. Well, if you have, oh, I'm sorry. I'm sorry, what's that? Oh, nickel support. So in .NET, we're probably going to implement a LINQ provider first. And so the result set right now that you get back from a query is already an IEnumerable. So you can hand it off or use a LINQ to object to continue working on it. But we'll probably be implementing a full-on LINQ provider first, and then we'll evaluate nickel in the future. Well, if anybody else has any more questions, I'll be available after, or you can submit them to our mailing list here, or you can contact me directly via email or Twitter. So once again, thanks for coming, and enjoy the rest of the conference.